Good afternoon, everybody. Thank you all for joining today's webinar, Association Rules for Data Mining Beyond Market Basket Analysis. On today's call, we have myself, Kristen Brown, Marketing Events Manager with Ironside. I'll be moderating today's call. And then we have Pamela Askar, who's a data scientist with Ironside. Just to let everybody know that all Q&A will be held till the end of the call. And any questions you have during the presentation, just type them into the dashboard and I'll flag them all for the end, and Pam will answer them at the end of the webinar. So now I'm just going to hand it over to Pam.
Thank you, Kristen, and thank you everybody for joining. We're going to talk about association rules today and how they can be applied to different industries and different applications beyond just the market basket analysis that they're traditionally known for. And I'll give a demonstration of how to do this using SPSS Modeler. Association rules can be used, conducted in R or SAS or whatever tool you want to use for data mining. I'm going to show it in Modeler because it's a very visual tool, and so if you're new to data science, I think it's very easy to follow along and understand rather than seeing somebody's code if you don't know the language. So just quickly before we jump into that, I just wanted to introduce Ironside and who we are. We offer strategic consulting and business analytics advisory services across a number of domains. We're best known for business intelligence, but if you need assistance in any of these areas, feel free to reach out. There's a number of options that we do, and I'm sure we have a team that would be able to help you with that. Just some numbers to demonstrate who we are. We've been around for a little while and have lots of happy clients. So that's kind of who we are. And we service a lot of different industries. I'm pointing this out because as I talk about association rules, I'm going to try to give examples of where they can be used in a number of different industries. And so I wanted to just point out that these are just a few of the industries and applications that we service here at Ironside. So what are association rules? Well, I'm sure you know they're a data mining technique, and that's why you're here. It's a very simple algorithm underlying the process that goes through a historical data set looking for probabilistic if-then statements. So this is really how Netflix works. So if you go on Netflix, I'm sure you see a number of recommendations for you. Since you've watched all these shows, you might like Breaking Bad or Mad Men, for example. And so if we look at this really tiny data set here, we can get a sense of how they do that. If we just had 6 individuals and looking at 3 different shows that they may have watched, we can find some probabilistic if-then statements in here, or what we're going to call rules, specifically association rules. For example, 50% of the people in this data set watched Mad Men, right? 3 out of the 6. And of those 3, 2 of them also watched Breaking Bad. So we have an association rule right there where Mad Men and Breaking Bad are associated with each other. 66% of the people watch Mad Men watch Breaking Bad. So that's just one rule that can be extracted, and it's a very simple algorithm, as you can see. And just a level set as we get a little bit further, there's some terminology that's specific to association rules, but it's tool general. So whether you're doing this in R or SPSS, kind of the same terminology. The antecedent and the consequent are 2 different parts of that rule. Excuse me, the if part and then then part. So in a rule, if you watch Mad Men, then you might like Breaking Bad. Mad Men's the antecedent. And there can be one antecedent or there can be many, and that's really where the value of this comes in, looking at these unique clusters of items that can predict the consequent. And the consequent is usually just one item. You can think about it as the final prediction. So if you liked A, B, C, and D, then we predict you're also going to like this other item. The support, confidence, and lift, these are metrics that you can use to evaluate the rules and decide which rules you want to keep or discard. So the support is how frequent that whole antecedent part of the statement occurs in your data set. And the confidence is how frequently that antecedent is associated with the consequent of interest. And the lift is the ratio of the rule consequent to the prior probability of the consequent. So a quick example, if Breaking Bad was watched by 20% of your sample, then that's its prior probability. And if you found a rule like if Mad Men then Breaking Bad, and its confidence was 60%, well, that's 3 times the prior probability. So you could say that you found a rule that says that those who watched Breaking Bad are 3 times as likely to enjoy those that watch Mad Men are 3 times as likely to enjoy Breaking Bad than the average person would. So that gives you kind of a sense of how to compare this to the rest of the sample. The support and the confidence are also criteria that you're going to set when you set up your model. So in a real data set that's very large, you could have thousands of rules. And you don't want all of those that occur when, just one individual watches something and they watch something else. So you're going to set, only pull out rules where the support is 20% or 5%. And we'll talk about what those might be. So if we go back to this example again of this mini data set, say we want to specify a consequent of interest, which you can do using an a priori method of association rules. Maybe we have some vested interest in knowing how do we predict who's going to watch Breaking Bad. From this mini data set, we could pull out 2 rules. If Mad Men, then you might like Breaking Bad, and if House of Cards, then you might like Breaking Bad. You can see the support, confidence, and lift for each of those rules. Now the first rule occurs far more often, right? It's 50% versus 33% of the second rule. So you're hitting more individuals. But how do you balance that with the other metrics there? Just a few things to think about, because there's really no hard and fast rule or cutoff to say this is a good rule, this is a bad rule. It really depends on your use case, how balanced your data is, the size of the data set, and the ultimate goal of what you want to do with this when you deploy it. So I've worked with cases where I'm trying to predict a specific consequent, and that only happened in maybe 5% of the entire sample. So I can lower my threshold for support very low. I've even gone as low as like 0.1%, right? I want to find rules that might occur very rarely, but when they do, they're strong predictors of that, that event that I'm interested in. So that second rule, it only occurred in 33% of the sample, which is actually quite a bit, but by comparison to the first rule, it's low. Now you can see it has 100% confidence. So when people watch House of Cards, 100% of the time, they watch Breaking Bad. The first rule, you can also see that the lift is below 1, so it's really not adding any value anyway. So now that we have an idea of association rules and how they work, let's talk about some ways to apply them and make use of them. The best known example is market basket analysis, which searches historical purchases to identify items that might be purchased together. So you've probably heard some examples of this. The best known example is if you were to buy bread and diapers, then they predict you would buy beer. So bread, diapers, and beer are bought together. On the surface, that might seem very unrelated, or maybe if you're a parent, that's actually very relatable, and you know that you always buy those things together. But that's something that came out of a market basket analysis. Now, why would you want to do this? Find items that are purchased together. The best reason that most often comes up is to make suggestions to your customers about what else they might like. So I'm sure if you've been shopping online, you put some things in your cart, and you see at the bottom or the side of the screen some suggestions. You may also like X, Y, or Z. Another reason might be to figure out how to display items in the store or online, kind of putting things that are purchased together near each other to make that suggestion that they might also want to purchase something else. And in some cases, you can predict demand of items based on the sales of others. A lot of the examples we come up with, they, it kind of makes sense that two things would be related to each other, but a lot of times the patterns that you pull out, they're very non-intuitive, and you may have missed the fact that these items would be purchased together or are related somehow. So you may want to run this and then be able to predict, you've had high demand of a certain item or a set of items, you may also want to think about stocking up on something else that's related to it. Now what I want to do is kind of talk about going beyond market basket, because association rules are used for market basket analysis so frequently that sometimes the two terms are used interchangeably, and you can move beyond that. And before I pull this into other industries really outside of retail and too far away from market basket, I wanted to talk about some ways to just expand on market basket analysis and think about it in a few different ways. So one thing that people are doing is using association rules to look at what people are viewing on their website. So it's not just tracking what pages are viewed the most often, what things are clicked on the most, but kind of a pattern of looking across different pages on your website, looking for different material, clicking on different ads, to really understand that customer base. I mean, you can almost segment customers based on these types of patterns, but you can also then make suggestions and know better where to put links to different pages to see that kind of sequential process. There is also a sequential method for association rules. So if you really wanted to look at the order of purchasing things, like not just you have a whole bunch of things in your market basket, what else might you be interested in, but specifically if people did X, then Y, then Z, what might they be looking for after that? Another example that's come up recently, probably because I'm expecting my first child, but I've noticed the way that retailers have changed their messaging to me in their ads, except for like Nordstrom, who continues to send me ads for 4-inch heels, like on a weekly basis. So they haven't quite caught on that there's been a shift in my life and I'm not anywhere near being in the market for 4-inch heels anytime soon, right? But a lot of other retailers have. And the reason I bring this up is because it's not just about looking at what people are purchasing and suggesting one or two other things. You can put in to your data set like a specific life event and try to predict that based on purchase history and really predict when there's been a massive shift in someone's priorities, in their lifestyle, and their views. That can change not just single ads that you send to customers, but really the way that you treat them and message them. It's really about a real qualitative shift in who they are as a customer of yours. And finally, you can also use market basket analysis to look at people responding to online offers. You know, which ones do they respond to, and if there's a certain type of offer or ad that people continue to go to, you know, you can kind of cluster those in that way. Same way you would with items in a market basket, but kind of looking at offers to figure out what really resonates with different types of people. So these are all really still in that market basket domain, but kind of tweaking it a little bit. I'm going to talk about some use cases now that go really outside of that to other industries and to really using association rules for classification, for prediction, and sometimes even in that unsupervised way, similar to market basket. So one thing that we've had success with recently is classifying injury types based on diagnostic codes. So if you have, say, like 1,000 ICD-9 diagnostic codes, you can use that to try to classify what was the cause of the injury that sent the person to the hospital that day, or to get treatment. This is useful for insurance companies who may want to, say, identify when someone's injury was actually caused by a car accident, and therefore they should be billing their auto insurance, not their health insurance. Or, say, detect when someone was in a car accident, wasn't really hurt, but then went home and fell off a ladder, and now they're trying to say, oh yeah, that broken ankle was actually from that car accident, right? It's not just about saying this particular injury is highly associated with, say, a car accident, but this pattern together really signifies a particular cause of an injury. And we've had some success with that recently. Another thing that you can do, say you have some text data, it could be social media, qualitative survey results, adjuster notes, any text that you have, you could first apply text mining to that to pull out categories, topics, phrases that are talked about over time from the same individuals, and then apply association rules to see what are these associated themes that continue to arise together. And that's really not even industry specific. That could apply to a number of different areas. In the biology world, they use association rules frequently to try to classify species based on characteristics. And I think that's kind of a classic categorization use case that you could think of being applicable to a number of other domains as well. In academia, you can do this with courses that have been taken or with performance in courses to kind of predict overall academic performance and success. I've seen this done where continuous data then needs to be kind of grouped because association rules is typically done with binary or nominal data. So if you had some continuous scale, you may want to bin that down. It's also used to identify patients that might be at risk for a heart attack, a stroke, certain diseases based on prior diagnoses, based on characteristics. This could also be based on genome data. Sometimes a pharmaceutical company may want to find associated genes and genetic biomarkers that might suggest that they're more likely to respond to a trial drug. So there's a lot of applications in medicine as well. And finally, web or email filters. Just coming up with a set of rules that would say, based on the characteristics, words or phrases, this is spam or this goes to your inbox. That's another common application. So there's a lot of things that you can do with association rules. It sometimes gets overlooked just because it's thought of as the market basket analysis, and we don't often think about bringing it into other use cases. It's not always going to be the best option for you, though, so I want to balance out some pros and cons to really talk about when you might want to think about bringing this in, as opposed to more traditional techniques like decision trees or statistical models. Association rules are great for binary or nominal data, especially when you have a large number of inputs. If you're trying to do data reduction or clustering, sometimes it's just not appropriate to do that with this type of data. And the association rules allows you to do that, to kind of filter it down and come up with, instead of 1,000 fields, maybe 100 rules that you could then move forward with. It's very easy to understand, to conduct, to understand the underlying algorithm. I have the word KISS there, not because it's Valentine's Day coming up, but if you've taken statistics or methodology course, you may remember the term KISS, keep it simple, stupid. It's kind of mean, but it's a reminder that you don't always have to jump straight to the most complex, sexiest model out there. You really should be looking for the more parsimonious solution. And this is a very simple algorithm and simple to create and deploy. So just something to keep in mind as well. It's flexible for both supervised and unsupervised learning. And by that I refer to, you're trying to predict a specific event, someone's at risk of something, or someone had a certain type of injury, versus unsupervised learning, where you're just looking for associations in all of the inputs, like market basket analysis or Netflix, just show me groupings. It's a great option when you have imbalanced data or you're looking for very rare rules. If you had a target field and the target that you were looking for only occurred in, say, 5% or 1% of your sample, a lot of traditional data mining techniques can be very biased against finding that 5 or 1%, so it can be a little challenging. So that might be another clue to say, maybe I could try association rules, because it's not a statistical model. We have to meet a lot of demands. It's really just looking for those probabilistic statements, and you can set those thresholds as low as you want to find them. So it's a really good option for that. Some of the drawbacks, you may end up initially with a large number of rules, especially if you have a lot of inputs, that need to be trimmed back. And as I said, there's no hard and fast rule to say what's a good rule and what's not. You've got to know your data set. You've got to know your use case. What are you going to do with it? So you'll have to make some decisions about how to cut those back to a more manageable number if you have to. The training time can be long. This is a process of kind of sorting and resorting. It iteratively goes through the data set, and the larger it is, the longer time it's going to take. So it can be a longer training time, and this is typically mentioned with association rules. I haven't found it to be overbearingly long, but it may take a little bit longer than other methods. Also, instead of getting a predicted probability for every single case, you'll see this in the demonstration, if individuals don't meet any rules, and that will always be the case, you'll have people that, whatever set of rules you keep, there's going to be people in your data set or cases that just don't meet any of those rules. You kind of end up not knowing much about them and just having to remove them or give them a predicted probability of 0. And that might become more clear when we do the demonstration. This is not a great option for continuous data unless you bin it into the high, medium, low, something like that. If you leave continuous in there, then each individual value will become a category and the rules will just be completely unwieldy. So not a good option for continuous fields. So again, just to think about when you might want to consider using this, if you've got binary nominal data, especially a large number of inputs, if you have imbalanced data, you're trying to predict something that's very rare, you're trying to find patterns that you think very rarely occur and you want to pull those out, those are good options for association rules. So I'll turn now to doing a demonstration in SPSS Modeler. What you see at the bottom is kind of the stream that'll build out. So you see it's very visual, and I'll go through what each of those steps are just so that you can get an idea of the process. The data set that I'll be working with is a set of HIV patients that may be at risk of becoming infectious. In order for HIV to become infectious, there's a certain protease that will cleave. I'm going to tell you now I'm not a biologist or in medicine, so I don't know much about what all this means. But essentially, each patient has a group of 8 amino acids at a certain location. And so we're going to see whether or not they cleave, kind of whether or not that location splits. If it does, that's a good sign that they will likely become infectious in the future. So we want to predict, based on the particular and specific amino acids that they have, and maybe looking for patterns of them or groupings of these amino acids, who's kind of at risk of becoming infectious. And then given time, I may also just quickly touch on another example. This is data from MSNBC. They took all the page views of their online website across, I think it was a 1-year period. And so you can kind of look at when someone goes to the website, what are the different pages that they would view that would be viewed by the same person. So I'll show that one briefly. So this is SPSS Modeler. I won't give a full training on how to use it right now. We do offer formal trainings if you're interested. But I'm just going to kind of go through the steps. Like I said, this can be conducted in R and S, in any other data mining tool. But this is very visual, and I think it's a good way to just show you the process. So what I've done here is imported this data set, and I can preview it for you to show you the first 50 records. And what you'll see is that each individual patient has 8 rows. So this is set up in a transactional format where you would be reading, each row is considered to be a transaction. Again, thinking back to classic market basket where a transaction is an item purchased. In this case, each row is one of the 8 amino acids that they have present at that particular location. They also have a marker for whether or not that cleaved, right, suggesting that they're at risk to become infectious. Now you can conduct association rules in this transactional format. I'm going to turn it into the tabular format where there's one row per individual, because at least in Modeler, If you want to specify a particular consequent of interest to look at, it just needs to be in that format. So what I'm going to do is add this set to flag node, which will take all of the potential amino acids and turn them from one single field into each one being a field, a flag field. So it'll be marked as true or false, that individual has that amino acid or they don't. And I will aggregate this up to ID and cleaved. And so here's what that would look like. Now we have one row per individual, whether that protein is cleaved or not. And we have one column for each amino acid, and true if they have it. I'm going to add a type node, and this just reads in those fields and allows you to set properties. This cleaved, I noticed, came in as nominal, and I'm going to set it to a flag, meaning it should just read in as true or false, 1 or 0. Now, one thing we might want to do here before we start the model is learn a little bit about the data set. So let's just look at a distribution of cleaves and see how frequently that occurs. So we see that in this data set, the consequent that we're interested in, cleave, suggesting they're at risk, occurs in 23% of the patients. We may also want to look at all of those different amino acids. I'm just going to suggest all flag fields here and overlay cleaved on top of that. And what that does is show us how frequently each of those amino acids occurs in the sample, L being the most frequent. I'm going to change that and just normalize it by color. What that does is allows me to kind of look more at the red part of the bar, and that suggests the probability of each of those amino acids that are associated with cleave. Just a slightly different format here. If I do that, I can see that amino acid M seems to be the single most amino acid that's associated with cleaving. So roughly 48% of them, of people with this amino acid cleave. So we could make a rule right there. If you have amino acid M, you're at risk more so than the others. But we'd be wrong 52% of the time. So something just to keep in mind so that we look at this, we understand the data set a little bit before we move on. So I'm going to jump to building the model next. If I click on association rules, I'll choose a priori. The a priori method is the most commonly used method of association rules. Karma is very similar but doesn't allow you to specify the consequent of interest. If I open this, I can modify the model a little bit. I'm going to specify that cleaved is the consequent of interest. That's what I want to predict. And all these amino acids can be potential antecedents. If I click on model, here's where I can change some of the criteria. I do want to keep this checked, only true values for flags. I'm not really interested in, if A and C, then cleaved is false. I really just want rules that predict when cleaved is true. Now the minimum support and confidence, these are the default values. I'm going to set this at 5, and I'm going to set this at 70. Again, where you start with this depends on what you know of the data set, how rare the occurrences that you're looking for, what you want to do with it, what you're looking to get out of this. I usually tend to start on the lower end because once you build the model, you can filter right there within the output. If you set this too strict, you're going to have to go back and retrain the model. So it's kind of helpful to start as low as you think makes sense. And I will run that. Now that was really fast because this is a very small data set. But what I get here is a gold nugget. That's my output. So we can see here our rules, and I only have 7 rules, which is very small and manageable. Each row is a rule, so you see the statement. If you have MAVL, then we predict you will cleave. Now MAV and L occurs in 5% of the entire sample, but when it does, 90% of the time, these individuals have a protease that cleaves. So that's pretty high, pretty predictive, and we would suggest that these patients are at high risk of becoming infectious. One thing I can do is add some other metrics. I can look at lift. So now I can also say that these individuals who have amino acids M, A, B, and L are 4 times as likely to be at risk of infection than the average person in this data set. Now, 7 rules is quite manageable, but if I wanted to, I could filter some of these out, right? Say I had thousands, and I think that I set the confidence too low. I could set a filter there. If I want to look at antecedents with only, we said M was the most associated, I could filter this down to show me only rules where M is involved. So you can do a number of things here just to pull out a subset of the rules. Now my next step might be to deploy this, right, to score it. And so maybe I bring in a new data set here, new patients. I don't know if they're at risk or not. All I have is their amino acids. I can run it through the same string, just modifying this to pull out that single variable of cleaved. And actually, I'm going to jump to kind of a finished stream, just where I've already added these on, and show you what you get out of it. Before I do, let me just add a quick table. A table will just show you the entire data set. So this is our output model, right, that we just looked at with our 7 rules. And if I had a table on there, I can see the data set. What I want to show you is that if you scroll to the end, you get a few predictive scores. So this first one says, what's the prediction? Well, all these say null, and that's because they didn't have any of the rules. They did those 7 clusters of amino acids, so we have no prediction for them. This individual down here, though, we're going to predict that they did cleave. We're predicting that with 89% confidence, and it looks like it was specifically rule number 2 that they met. So we could always kind of go back to that to see why are they at risk, why are they getting flagged in this data set. What I did here was just pulled out only those that we predict are cleaved, so we get rid of all those nulls. We just want to look at the patients who are at risk. I sorted this by their confidence in descending order. And I filtered out all of these other fields that we don't need. And I did that to create a data set that, or a table that might be easier to work with. So when we're deploying this, we want, in the end, a list of patients that we think are at risk. We want to know how high is their risk. And maybe even we keep the rule about why they're at risk. So you could end up with this. Now a table here is just basically a temp table, a temporary table that would be deleted at the end. You can export this back into a database, to an Excel file, to a flat file, whatever you need. So that's kind of the process from start to finish of a little bit of data prep here, kind of building the model, looking at our rules, evaluating what we want to keep. In this case, we kept them all. It was a small rule set and quite manageable. And then kind of cleaned up a data set to export at the end to make some use out of. So I'm just going to quickly show you the other one, just so you see something that's more unsupervised, a little more classic market basket analysis. In this case, these are the MSNBC page views. So here's where we have multiple rows per individual based on how many different pages they went to. Pages are just numbered right now. They go through the same thing of setting them to flag so that they become their own column, their own field. And this is a little larger data set, so you can see that here. And you see there's no predicted field. This is an unsupervised where we just want to know what are some possible clusters, what are some possible associations between what people look at. We're not trying to predict or categorize any specific item. And then next up, I went back and changed those names because, page 4 is not that valuable to us, but knowing that that's local versus weather versus health, living, etc. is helpful. And when I ran this model, I arrived at 250 rules, so quite a bit more. But you can see, the rules. If someone goes to opinion, summary, and miscellaneous, they may also be interested in some on-air pieces. And that can tell us a bit about who's going to read it, what are they interested in, what else could we suggest to them. And again, you can go in and filter, and maybe we only want to look for who's looking at health or living pages, and we can look at those specific rules. So I hope that shows you kind of what you can do in Modeler, but also with any tool with association rules, kind of what you get out of it, the process, and thinking about a few different applications and new ways to use association rules.
Thanks, Pam. Now we are going to open it up for Q&A. So if you have any questions, just type them into the dashboard there, and we will go over them shortly. All right, so while some of the questions are coming in now, I just wanted to go over just some next steps. And after this webinar, you may want to take advantage of this special offer. But what we can do for you is you can download a free trial of SPSS Modeler, and you can visit this link. Just type in the link below to your browser, fill out a form, and then we'll be able to give you access to dataset and go through the trial of SPSS Modeler, and we'll be here to help you along the way, and Pam will be available throughout this process as well. So one of the questions that have come in is, how does this technique compare to decision trees or other data mining techniques?
Sure. So there's a lot of different ways to categorize and think about different data mining techniques. Decision trees kind of get clumped together in statistical models, and then you can think of like clustering models. And association rules are usually on their own, kind of to the side, and that's partly because the underlying algorithm is just different. It's a different approach. It's also because it's not vetted for just supervised or unsupervised learning, not just prediction or clustering. It's very flexible and can be used for a lot of different categories. So I think it's simpler and easier to use than some other data mining techniques, but also what you get out of it is a rule set as opposed to your more traditional predicted probabilities or predicted scores.
Great. Can you export a list of the rules into a text or Word document?
Yes, that's something that I can show you right here in Modeler. If we go into our output where we're reviewing the rules, sometimes there's a lot of rules, and clients say, can I just have a list of what the rules were? I want to go over them, turn them over to management. We want to think about, what does this tell us about our data? So that's something that you could always do here. You could export the model, and that would give you a text file. And it would look like this. So that looks like something you may want to paste into Excel and kind of look at. You get the support the confidence there. If you wanted the lift and other metrics, you could add those as well. But sometimes that's really helpful to just get a list of that, especially if it's you know, a lot of rules that you may want to think about how those apply and what they mean.
Okay, next question is, does every case in the data set get a single prediction, or will it provide all possible outcomes?
That's a good question, because that's another way that this is unique to data mining, other more traditional types of data mining techniques. You can imagine cases where individuals are going to meet more than one rule, right? They may have a few of those clusters of the amino acids. They may watch a lot of Netflix and have a lot of different moods and categories that they like, and there's a lot of different things that you could predict. So it's actually something that you can set right in here. So if I go to summary, right now I have this set on maximum number of predictions is 1, but I could increase that to 3, say. And I always want to rank that by confidence. That's kind of what makes the most sense, so that the first 3 rules that pop up, or in my case the first 1 rule that pops up, would be the one that they met that had the highest confidence. Right? We wouldn't want to say, well, they met rule number 2 before they met rule number 3. It has a lower confidence, but you'd kind of be underestimating their risk in that case. But if I said this person had 3 predictions, right, they would just get 3 sets of these predicted scores. They would get a prediction, a confidence, and which rule it was that they met. And in this case, there would be 3 of those. And you can make as many of those as actually make sense for your particular case.
Okay, thanks, Pam. Well, we don't have any more questions that have come through, but if you think of anything after the fact, we'll be available to answer those questions. An email in about 30 minutes will be sent out to you with a short survey. If you have a few minutes of your time, we'd really appreciate the feedback. And in addition, the copy of the deck and the replay will be available. Usually it takes us a couple days to get this out, so be on the lookout for this early next week. Thank everybody for your time today, and have a good rest of your afternoon.